Hey guys, this is Coach Lowe, and we are in Chapter 4, Section 4, and we're talking about proving triangles congruent, and today we're going to talk about side, 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 angle, side. So we have two triangles. We're trying to see if they're congruent or equal in measure in angles and sides. So if we remember from previously, we talked about if we have two triangles that are congruent, then their corresponding parts are congruent. Or if we can show that corresponding parts are congruent, then the triangles are congruent. All right, so postulate 4.1 is side, side, side congruence for a triangle. And it says if three sides of a triangle are congruent to three sides of another triangle, so they match up and they're congruent, then the triangles are congruent. That's the side, side, side congruence theorem or postulate. So here's the problem in question. Is triangle MNO congruent to a triangle QRS? All right, so remember we talked about when these are written, triangles are written, and they ask about congruence, there's a certain order we need to go in. We want to know, is MN congruent to QR? Are they the same measure? Then we want to know about NO and RS. All right, so then we've got these guys right here. Then we want to compare MO. This is very important because if you don't do these in order, you could get that they're not congruent when they really are, to QS. So we want to do it just like it's written, MN to QR, NO to RS, MO to QS. All right, so those are our comparisons now. We know how to find side lengths. We know how to find distance between 2 points. So you can graph this if you wish, but we just need the length of this segment from M to N. All right, so remember, sides of a triangle are segments. So we need the length of this segment. So yeah, we're going to bust out with distance formula, right? So distance equals x2 minus x1 squared plus y2 minus y1 squared. Who knew we would use that distance formula so much this year, right? We're excited about that, I know. All right, so here, distance. We're looking at M and N. All right, so x2, so -1 minus 0. So x2 minus x1 squared plus y2 minus y1 squared. So y2 minus, and I have a -1, so it doesn't matter if this is positive or negative. We're plugging it in. This is still minus until we get to this point where we can say, oh, minus a negative. Let me get that little squared on there because I'll forget it. You guys know that. So this changes to plus. So now I have the square root of -1 squared plus -4 plus 1 is -3 squared. So the square root of 1 plus -3 squared is 9. So the square root of 10. All right, now I want to look at this guy right here. I want to look at QR. So I have the square root, and we're looking at these guys. So 4 minus 3 squared plus -4 minus -3 squared. So that is the square root of 1 squared. I already see a problem. Do you see it? Plus -1 squared, which is square root of 1 plus 1, which is a square root of 2. All right, so MN is the square root of 10. QR is the square root of 2. I can stop right there. I have two sides that are corresponding. They're supposed to be in the same spot. They are not equal to each other. So my corresponding sides are not equal to each other, which means my triangles are not congruent. Corresponding sides are not congruent. Triangle's not congruent. So luckily, look how lucky we are. We get to stop right there. Now, I like to do it this way where I'm comparing the two sides. Instead of finding all three sides of this triangle and then finding all three sides of this triangle and comparing them, I like to compare side to side because the first one that doesn't match up is a no. All right, hopefully that makes sense. The next postulate is 4.2. So postulate 4.2 talks about side angle side. So it's the side angle side congruence. And side angle side congruence says if you have two sides and the angle that's between them, so the included angle, if I have two sides and the included angle in a triangle, and those are congruent to another triangle's two sides and the angle between them, then the two triangles are congruent. So let me draw a picture of that one. Side, side, side's not too bad. Side, angle, side can be a little crazy. All right. So let's say that we're talking about these two sides and this angle between them. See how these two sides make up this angle, so that will be the angle between the two sides. So we're talking about this angle and those two sides. So side angle side would be AB is congruent to DE, CB is congruent to EF, and angle B is congruent to angle E. That is side, angle between them, and then side. All right, so that is postulate 4.2. All right, so let's look at a problem and see if you guys can figure out if this is side, angle, side. All right, so looking at this figure, I've only marked two sides here. So I have two triangles. Do you see the top triangle and the bottom triangle? So I've marked that this side is congruent to this side, and this side is congruent to this side. It would appear that we just have side, side. We don't have the other side, so it's not side, side, side. But do you know that two angles are congruent in these two triangles? So think about that. I have two lines intersecting. What do I know? Yeah, exactly. These are vertical angles, and vertical angles are congruent. So this and the angle is between the two sides. It's included, formed by these two sides. So I have side, angle, side. Side, angle, side. Yay! So this is side, angle, side congruence. The top triangle is congruent to the bottom triangle. Now, here's what that gives me. Because I know that, that means corresponding parts of congruent triangles are congruent. So I know these two guys are congruent to each other, and then I also know that the angles are congruent to each other. This angle goes with this one, and this angle is with this guy right here. So awesome sauce. We are finished, and I will see you guys soon. This is Coach Lowe, and I'm out.